Okay, this is chapter 12, which is the talking about gases mostly. We're going to get into chapter 13 as well, but we're going to start out with section 12.1, the behavior of gases and the kinetic molecular theory. We're going to start out with the kinetic molecular theory, which started out with 5 main postulates. We're going to focus on just kind of a few ideas with the kinetic molecular theory, which is going to head into gas laws. And so you need to basically understand these ideas with the kinetic molecular theory. We're going to focus on these kind of key ideas with the kinetic molecular theory with ideal gases. So what you need to understand is that with an ideal gas, that particles have no volume, meaning that within a gas itself that the particles are spread so far apart that they just have no volume in itself, that they have no measurable volume. So you need to understand that. They have no elastic collision. So as far as when they hit each other, that the collisions within themselves are elastic, meaning that a lot of times when things hit, that they lose energy. And so the collisions, a lot of times things hit, they lose energy, and they just, eventually they just start to fizzle out. But elastic collisions actually don't lose energy. They keep the energy that they have. And so that's what an elastic collision is. They are in constant, straight line, random motion. Particles in an ideal gas, they attract or repel each other. So that's something else that you need. They don't attract or repel each other. So they have no attraction to each other whatsoever. So that's something else that you need to know. And then also that they have an average kinetic energy that is directly related to the Kelvin temperature. And so that means, first of all, kinetic energy is a measure of the motion of the molecules, meaning how fast they're moving. So Kelvin temperature is actually, temperature in itself is a measure of how fast particles are moving. So it kind of makes sense that temperature itself is a measure of the kinetic energy of a particle. So that's why they're directly related, because temperature is a measure of kinetic energy. So as temperature goes up, kinetic energy goes up. So those are just some things that you need to know about basically what the kinetic molecular theory is. So some other things just about real gases versus ideal gases. First of all, in reality, we have real gases. They have their own volumes. They attract each other. So those are things, obviously, that you need to know. Gas behavior, of course, for the most part, is ideal at certain circumstances. So it's at, of course, low pressures. You get those ideal circumstances. So low pressures meaning that there's less collisions. If we have really low pressures, meaning that there's not a lot of room for them to hit each other. There's meaning that you have lots of space. You think about, you have a container that's really, really large. There's not a lot of places for them to hit each other. So that's an ideal situation. Another place that you have an ideal gas would be at high temperatures. So they have lots of room to move. There's lots of places for the kinetic energy in order for them to allow them to move around. Also, non-polar gases are also ideal, atoms or molecules, because they don't stick together. They only have those London dispersion forces. Remember that London dispersion forces are the ones that are the weakest attractions. They just kind of interact and then let go. They're not hydrogen bonding or dipole-dipole. So those are your ideal gases. Those are the ones that interact. And of course, we're going to focus on ideal gases because those are ones our equations work with. And for the most part, gases do act in an ideal situation because a lot of times we put them in those situations where we have low pressures, high temperatures. And if you think about it, most of our gases are nonpolar. So that's why we deal with these ideal gases. So for the most part, we do put them in situations where we have ideal gases, but a lot of times too we have real gases in, of course, the real world, if that makes sense. It's just some characteristics of gases that you've probably learned over time, and we're just going to review here real quick. Of course, hopefully you know at this point that gases expand to fill any container they have, random motion, no attraction to one another. They're fluids, meaning that they flow. Again, they have, no attraction to one another, so they're allowed to basically flow over one another. They have very low density, meaning that if you look at the picture below, look how solids are real packed together, liquids are a little farther apart, and the gases are really spread far apart, so you have lots of empty space. And of course, this should be nothing new to you. Just some information that you should put kind of in your, need to know bank. Standard temperature is 0 degrees Celsius and 273 Kelvin. Standard pressure is 1 atm or 101.325 kilopascals. And we'll talk about what a kilopascal is later when we talk about units of pressure. We'll do a lot of pressure conversions, but we talk about conditions and we say that this only happens at standard temperature and standard pressure, and so these are these conditions. So I wanted to make sure that we put these in your notes. And that's kind of the end of this video for today. So this is our first video, so I wanted to kind of give this opportunity to talk about what ideal gases were and put some information about the kinetic molecular theory. So we'll be going through in class and discussing further the kinetic molecular theory a little bit more and giving you some demonstrations. So make sure you go back through the video and look at this video more thoroughly, and we'll see you in class.